So you've written a Dockerfile. You know how good it feels to get something up and running on your own machine. But what does it really take to get that simple script ready for the big leagues, for production? It's kind of like the difference between a quick napkin sketch and a full-blown architectural blueprint. And that's exactly what we're going to dive into today. I want you to think for a second about your current projects. Is your Dockerfile just a thing that happens to work for you locally? Or is it truly battle-tested and ready for a live environment? Because that difference, well, it can be the difference between a smooth deployment and a frantic late-night emergency call. So what's our goal here? A truly production-ready Dockerfile nails 4 key things. First, it's got to be secure, with the smallest possible attack surface. It needs to be lightweight, so it's fast to pull from a registry. It has to be consistent, building the exact same way every single time. And finally, it has to be fast to build and deploy. Because in a modern CI/CD pipeline, speed is everything. To get there, we're going to frame this whole thing around 3 core pillars. First up, we'll focus on minimization, making things small and fast. Then we're going to tackle security and how to harden our images. And finally, we'll cover reliability, making sure everything is standardized and stable. Okay, pillar number 1 is all about pure efficiency. We want to create the smallest, fastest container images we possibly can. And look, this is about way more than just saving a little disk space. This directly impacts your build times, your deployment speed, the whole shebang. So how do we actually do this? Well, it all starts with picking a minimal base image, like Alpine or even distroless. Next, you absolutely need a Docker ignore file to keep junk like your node modules folder or log files out of the build context in the first place. Then, you want to get smart about ordering your commands to take full advantage of Docker's layer cache. And finally, always clean up temporary files before the image is finalized. Just these steps alone will make a massive difference. Now for the most powerful technique for minimization, hands down, the multi-stage build. In this first builder stage, we don't care about size. We use a full-featured image that has all the tools we need, like the entire Node.js toolchain. We install all our dependencies, we run our build command, we make a mess, and that's totally okay. And this is where the magic happens. In stage 2, we start over, completely fresh, with a super minimal base image like nginx alpine. Then, using that special copy from command, we reach back into our builder stage and pull out only the compiled application artifact, the thing we actually need. The result? A tiny, production-focused image with 0 heavy build tools or development junk. This is a total game changer, not just for size, but for security too. By ditching that whole build toolchain, we've just massively shrunk our potential attack surface. All right, so we've got a lean, mean, small image. Now we can shift our focus to pillar number 2, security. Let's be real, a container running in production is a potential target, and it is our job to shrink that target as much as possible and harden its defenses. If you only take one security tip away from this, please let it be this one. By default, containers run as the root user. That is unbelievably dangerous. If an attacker finds a way into your application, they suddenly have root access inside that container. You have to add this line, create a non-root user, and then switch to it. It dramatically limits the potential damage of a breach. This might seem super obvious, but you would be shocked how often hard-coded secrets pop up. Putting passwords or API keys right into your Dockerfile is a massive security risk. Anyone who can get a copy of that image can just inspect its layers and see your secrets in plain text. Don't do it. Instead, use proper secret management tools like Docker Secrets or inject them from your CI/CD system. Okay, let's talk copy versus add. They seem pretty similar, right? But add has some magic features like fetching files from URLs or automatically unpacking tarballs. And that unpredictability can actually be a security risk. The best practice here is super simple. Just always default to copy. It does exactly one thing and it does it well. It copies files from your build context, it's predictable, it's simple, and it's a whole lot safer. You can't fix a problem you don't know you have, right? That's why automated vulnerability scanning is absolutely essential. Tools like Trivy or Docker Scout can scan your base image and all its dependencies for any known security holes, what we call CVEs. This lets you catch and fix these problems before they even get close to production. We've made our image small. We've made it secure. Now for our third and final pillar, we need to make it standardized and stable. This is all about making sure our containers are predictable, reliable, and behave exactly how we expect them to when they're running for real. This one is so simple, but so vital for reproducible builds. If your Dockerfile just says from node Alpine, you're using the latest tag. That tag can change tomorrow and suddenly introduce a breaking change that brings your builds to a halt. By pinning to a specific version, like Node 20 Alpine, you guarantee that your build environment is consistent and stable today, tomorrow, and a year from now. Entry point and CMD, they confuse a lot of people, but the roles are actually pretty clear. Think of entry point as setting the main job of your container, the executable that always runs. CMD, on the other hand, provides the default arguments for that entry point, and those arguments are super easy to change when you run the container. So your entry point might be /ping, and your CMD could be /google.com. That way, someone could easily run your container and just type yahoo.com to ping a different host without having to mess with the core executable. All right, let's wrap this up with 2 final touches for a truly production-ready container. First, the expose instruction. Now, it doesn't actually open the port, but it acts as critical documentation for other developers and tools, clearly saying, hey, this application is supposed to listen on this port. Even more important, though, is the health check. This gives something like Kubernetes a way to ask your container, hey, are you okay? It goes beyond is the process running and asks, is the application actually healthy and ready for traffic? This is what stops traffic from being sent to a container that's technically alive, but not actually working. So as we've seen, all these best practices are really more than just a checklist of commands. They represent a fundamental shift in how you think, moving from just making it work to actually engineering a container that is robust, reliable, and ready for the real world. At the end of the day, that's the goal, right? A container that is secure, reproducible, minimized, and easily deployable. When you master things like multi-stage builds, non-root users, caching, and health checks, you are building containers that can handle the real demands of a production environment. So now, I'll turn it over to you. Looking at your own projects, what's the one change you can make right now that's going to have the biggest impact? Will it be switching to a multi-stage build, or maybe just adding that crucial health check? Thanks for tuning in.